Good morning, students. Welcome to the class on advanced organic reagents. Today we will discuss about Tebbe olefination. What is Tebbe olefination? We have just seen Wittig reaction where we can convert an aldehyde or a ketonic carbonyl group into an alkene. Now we will see the conversion of any carbonyl into alkene, conversion of any carbonyl into alkene using Tebbe reaction. Conversion of any alkyne into any carbonyl into alkene using Tebbe reagent. What is Tebbe reagent? This is Tebbe reagent. Tebbe reagent name titanium. It is just a complex of titanium and aluminum. It is a complex of titanium and aluminum. Now, I said any carbonyl can be converted into an olefin. What is the X? X can be hydrogen in the case of aldehyde, or ketone, or aromatic ketone, or it can be ester, it can be amide, it can be amide, or it can be anhydride, it can be anhydride, or as I said OR, it may be OTBS or OTMS, even it may be carbonyl selenium or carbonyl sulfur. So that means a variety of carbonyl compounds can be converted to alkene using Tebbe reagent. Sorry guys, please take this correction. These are not for Tebbe. These groups are not for Tebbe olefination. Please take this correction. Tebbe olefination is a very strong olefination so that any of these carbonyls can be converted to alkene. Now we will see how we generate Tebbe reagent and then how we convert carbonyl into olefin. This is called titanosine dichloride. CP means cyclopentadiene. CP means cyclopentadiene. Like ferrocene, when we have two cyclopentadienes and a metal, we will call them metallocene. So it is titanosine dichloride. When it is treated with trimethyl aluminum, then we will generate our active Tebbe catalyst. This is the Tebbe catalyst. Of course, under the reaction conditions, it undergoes further decomposition to generate titanium carbene, or what we can say titanosine methylidine. Titanosine methylidine. This is the active catalyst. Of course, this will be converted to this in the reaction mixture. This is not stable. This will immediately undergo reaction with carbonyl. So we will take this as a catalyst. In the reaction, it will be converted to this. Of course, here we are losing one two methyl groups and HCl. When we lose this from the catalyst, we are generating this titanosine methylidine. This is the active catalyst. Then when we add an carbonyl, when we add a carbonyl, of course the mechanism is same. It will undergo a 2+2 cycloaddition. It will undergo a 2+2 cycloaddition to generate this 4-membered ring. Then this 4-membered ring will undergo a 2+2 cycloreversion in such a way that oxygen will be leaving with titanium and the methylidine will be leaving with carbonyl carbon. So we are generating oxygen, titanium oxide, titanium oxide plus CH2. So the mechanism very similar to metathesis or Wittig reagent, but here the active catalyst is titanosine dichloride, which is a very strong uh, carbene than Wittig reagent. So that is why variety of carbonyls can be converted to alkene using Tebbe reagent. Tebbe reagent can also be generated from titanosine dichloride by treating with methyl lithium or methyl grignard reagent. When we treat these, two halogens are good leaving groups, so they can be replaced with methyl groups. This is called petasis reagent. Titanosine dimethyl titanosine is called as petasis reagent. Under the reaction conditions, what will happen? It loses methane gas. That means this methyl group will pick up another proton from here, so it leaves as a methyl gas and it generates titanosine methylidine. The actual active Tebbe reagent, right? This reagent, it is called as petasis reagent. Petasis reagent under the reaction conditions will be converted to the active Tebbe reagent. In this case, it is even more reactive than Tebbe reagent. Petasis reagent is even more reactive than Tebbe reagent. In addition to the functional groups which will undergo olefination, Tebbe reagent covers even some more functional groups. For example, I am discussing about the X. If you have an amide and on the amide if you have a withdrawing group, then also uh, petasis reagent will convert that carbonyl into olefin. If it is carbonyl bonded to selenium, then also it will convert that carbonyl into olefin. If the ester is acid, carboxylic acid is protected as OTBS or OTMS, then also it will work. Or if carbonyl carbon is bonded to sulfur, then also it will work. So that means petasis reagent is even more advanced and more reactive compared to Tebbe reagent. Now we will see some examples for Tebbe olefination reactions. As we have discussed, Tebbe reagent is more strong carbene, strong strong metal methylidene. So it converts esters, anhydrides, amides, aromatic ketones, of course normal aldehydes and ketones, all of the carbonyls into alkenes. We will be doing this reaction at little higher temperature. Then what will happen? This C double bond O will be converted to C double bond C, C double bond C. Okay. I'll give you some more practice problems. You write the product. So when you want to predict the product, it is just make this, remove this oxygen, that's it. Okay, when you want to write the product, what we need to do, we need to convert oxygen into carbon, that's it. So when you are writing the product, you just remove oxygen. So that's it. Here we have two lactone groups, so we need excess reagent so that we can convert both lactone carbonyls into alkenes. Mostly Tebbe olefination is used for to generate terminal, exo and disubstituted alkenes. Terminal, exo and disubstituted alkenes. when we use excess reagent, all the carbonyls will be converted to alkene. But if we want to differentiate two different carbonyls, if we want to differentiate two different carbonyls, what we need to do, we need to use only one equivalent. In this case, we have both ester and ketone. Which one will react faster? Of course, ketone will react faster compared to ester. So, ketone will be converted to alkene, ester will be there. So, when we use excess reagent, yes, both the carbonyls can be converted to alkenes, but when we use one equivalent, it is also possible for us to differentiate between two different carbonyls. The last example, we can also have variations in this reagent. For example, instead of methyl groups, we can go for some other alkyl groups, so that what will happen in the olefination, previously we have used methyl group, so it was CH2, but here we are using cyclopropyl group, so it must be this product. So what is Tebbe olefination? Conversion of carbonyls into alkenes. It is like a Wittig reagent, but it is even more stronger, so that it can convert variety of carbonyls into alkenes.